This is a fairly typical exam question that you might be faced with. In order to answer it, we need to know exactly what it means. To do that, we're going to look at 3 of the words in the question. The first word is product. Product is another mathematical word that simply means times or multiply. Factors are numbers that divide into other numbers without any remainder. For example, if I said the factors of 10, then I'd be talking about 1, 2, 5 and 10 because they all divide into 10 without any remainders. And then prime numbers. We're going to look at prime numbers in a little more detail now. Let's have a look at 2 different numbers. Let's have 18 and 13. Now, one of these numbers is a prime number and the other one isn't. And the way to tell is to look at the factors. Now, 18 could be written as 1 times 18, that's a product. It could also be written as 2 times 9, that's another product, or even 3 times 6. All of those make 18. There are no more, so the number 18 has 6 factors. 1, 2, 3, 18, 9 and 6. Those are the factors of 18. Now 13, on the other hand, can only be written as 1 times 13. That's the only way to do this using whole numbers and not decimals. That gives you a product to make 13. Now, that means that 13 is a prime number, whereas 18 isn't. So a prime number is any number that has exactly 2 factors. So a prime number is a number that has exactly 2 factors. So if it has any more factors, or even any less, it's not a prime number. If it has 2 factors only, it is a prime number. Okay, here are a list of 12 different numbers. You need to decide which ones of these are prime numbers and which ones are not. And if they're not a prime number, give a reason why. If you press pause and have a go at them, and then press play and I'll tell you what the answers were. Okay, here are the answers then. 7 is a prime number, 2 is a prime number, 15 is not a prime number, and for example it is 5 times 3, that makes 15. 20 is not, and you could say because of 4 times 5, or you could have 10 times 2. 21 is not as well because of 7 times 3. 9 is not because of 3 times 3. 1 is not a prime number, which is quite interesting because it only has 1 factor. Alright, and the only factor for 1 is 1. So only 1 factor. That's a common mistake. People think that 1 is a prime number. 18, well, we already said that's not a prime number. You could have 9 times 2 or 6 times 3. 19, that is a prime number. 14 is not because of 7 times 2. 13 is, we already knew that. And 12 isn't because of 4 times 3 or 6 times 2. So there were 4 prime numbers in our list: 7, 2, 19 and 13. Okay, back to the exam question then. Now that we know what product of prime factors means, let's have a look at how we would approach this question. What I would do is write the number 90 at the top of the page and then consider how I could split 90 into a product. Now you could split 90 into more than one product, but I'm going to go for 9 times 10 because that makes 90. You then ask yourself, these 2 numbers that you split it into, are any of them prime numbers? Well, 9 isn't prime and nor's 10, so you carry on. So 9, could I split that up again? Well, yes, I could split that into 3 times 3. And actually 3 is a prime number. When you get to a prime number, you put a circle around it to say stop. And 3 is again a prime number, so you put a circle around it. 10, that could be split into 5 and 2. And actually again, both of these are prime numbers, so I put a circle around them to say stop. Now I've finished, because there's no more numbers to split up. They're all prime numbers at the end of my branches, so I can write my answer to the question. This means that 90 is actually equal to all of these prime numbers times together. 3 times 3 times 5 times 2. Now, if your exam question says, as this one did, give your answer in index form, you need to write your answer slightly differently. You need to write 90 equals, and when you go through these numbers, and I like to do it in ascending order, so I'll start with 2 times 3 times 5, you need to group them together because we've actually got 2 3's times together here, which means 3 squared. So I put a little 2 up here to represent the fact that there were 2 3's multiplied together. So the final perfect answer to this question is 2 times 3 squared times 5. Okay, here are 8 for you to have a go at. press pause and have a go, press play again, and I'll tell you what the answers were. Okay, the answer is 100, that's 2 squared times 5 squared. 60, that's 2 squared times 3 times 5. 27, that's 3 cubed. 88, that's 2 cubed times 11. 120, that is 2 cubed times 3 times 5. 300 is 2 squared times 3 times 5 squared. 4,800 is 2 to the power 6 times 3 times 5 squared, and the last one, 200, is 2 cubed times 5 squared. Okay, the final thing you'll need to be able to do in an exam is use prime factorisation that you've just practiced to find highest common factors and lowest common multiples. To do that, you first of all prime factorise the numbers. So let's imagine we've done 90 and 120. Now 90 would actually come out as 2 times 3 times 3 times 5, which you could write as 2 times 3 squared times 5. And 120 would come out as 2 times 2 times 2 times 3 times 5, which you could write as in index form 2 cubed times 3 times 5. Now what you do is you create yourself a Venn diagram of these numbers. So we draw one circle over here, we draw another circle over here, and this first circle is going to represent 90, and the second circle is going to represent 120. And what you do is you look back at the prime factorizations and you go and find the numbers that are common to both of them first of all. So we have a 2 in this one and a 2 in this one, so I'll cross those both off and stick a 2 in the intersection. And well, we have more 2's in 120, but there's no 2's left in 90, so we can't use any more. But we do have a 3 in this one and a 3 in this one, so we can put another 3 in the intersection. And there's no more 3's now in 120. There is one in 90, but there's no more in both. And there is a 5 and a 5 we can use in both of them, so we can put a 5 in the middle. Now this means we've got some leftovers. For 90 we've got a 3 left over, so we can put that in here, and for 120 we've got 2 2's left over, so we can put those in here. Now from here it's actually quite easy to find your highest common factor and lowest common multiple. The way you find the highest common factor is you look at the things that are common to both of them. So in the middle here we have 2, 3 and 5. So our highest common factor is 2 times 3 times 5. And if you multiply that out, 2 times 3 is 6, times 5 again, you get 30. Now the lowest common multiple is simply all of the numbers that you see in the Venn diagram multiplied together. So this 3, 2, 3, 5, 2 and 2 again. So you'd need to do 3 times 2 times 3 times 5 and then times the final 2 2's on the outside. And if you multiply all those together, 3 times 2 is 6, times another 3 is 18, times 5 is 90, times 2 is 180, times another 2 is 360. Okay, here are 6 for you to have a go at. If you press pause, then have a go at those on your sheet, and then press play again and I'll take you through the answers. Okay, here are the answers then. I will do the highest common factors first and then the lowest common multiples. So for these first two numbers, 18 and 42, the highest common factor was 6. The lowest common multiple was 126. For 105 and 60, highest common factor was 15. And then lowest common multiple was 420. For 42 and 70, you were after 14, and then 210. For 75 and 90, you were after 15, and 450. For 25 and 75, you're actually after 25 and 75. And for the final question, if you managed it, the highest common factor was 60, and the lowest common multiple is 23,100.